We're going to be looking today at what we call special products. Now there's two really types of special products that we're going to be looking at, and one of them is called a perfect square trinomial, and the other one is called a difference of squares. And there are some patterns that you can use to multiply these out without actually having to do the multiplication, and that's great if you figure them out. What I'm going to do is I'm going to go ahead and show you how to multiply these out. Doesn't matter, it's going to work the same way every time. If you see the pattern and like to use it, that would be awesome. You can definitely do that, but I really want you guys to find that pattern on your own. If at any point in time you have a question about whether the pattern you think is true, just send me an email or send Mr. Ford an email, and we can tell you whether or not that is an accurate statement. So here we're going to start off with 2x minus 3 times 2x plus 3. And again, I'm going to go ahead and use FOIL, or you could use the box method, and then we're going to talk about this after we get it all multiplied out. So this is 2x times 2x, which would give us 4x squared. Then we would have 2x times 3, which would give us 6x. We'd have negative 3 times 2x, which would give us a negative 6x. And then we have a negative 3 times a positive 3, which would give us negative 9. Now what I want you to notice is that we still have those like terms in the center here, but one's a positive 6x and one's a negative 6x, so they'll actually cancel each other out, and you're left with just the 4x squared minus the 9. Okay, now I want you to kind of look at the problem and see why this happens. You'll notice that in the original problem, if you look at the signs, one's a negative and one's a positive, and other than that, they're exactly the same. And what that does is that causes you to have the same term, both 6x's, but one being positive, one being negative, so they always end up canceling. It's kind of a cool little trick. Also, I want you to look at your answer. Notice this is kind of the first time we've ever had one where we multiplied it out. Instead of getting 3 terms, we only got 2. This is actually that special case called a difference of squares. And because we're real creative in mathematics, we've named this very appropriately. Difference, if you'll remember, is the word for subtraction in mathematics. So you notice that here between my two terms is a subtraction. Squares refers to the fact that I can find a number that I can multiply by themselves. So for instance, 4 is the same thing as 2 times 2. That's a perfect square because it's the number times itself. 9 is also a perfect square because it is 3 times 3. So difference of squares, that's what we get, and that's why it's called that. And again, if you see it and you find out what the pattern is, you can definitely use that. However, if you just FOIL, it will always come out to the right answer. Alright, so for our next one, we have 9x plus 1 times 9x plus 1. And when you look at this, notice that they are exactly the same parentheses, same number, same sign, same everything. So these are going to be a little different than that perfect square where one was negative and one was positive. We're not going to see that canceling like we did that time. But we're going to go ahead and again use our FOIL. So we're going to do 9x times 9x, which is going to give us 81x squared. We're going to do our outside, so 9x times 1, which is going to give us a 9x. We're going to do our inside, so 1 times 9x, which is also going to give us a positive 9x. And then our last one, this is going to be plus 1. Again, our middle two terms are both x's. This time they're both positive, so I actually am going to add them together. They don't cancel each other out. 9 plus 9 would give us 18, so we would have 81x squared plus 18x plus 1. And again, because what we're doing here is we're multiplying the exact same parentheses times itself, this is our perfect square trinomial. Okay. Okay, so for our next example, we have this statement where we have 3x plus 5y, and then we're squaring it. And one of the things you have to understand is that when you're doing this, you actually need to write out the squared. So remember, squaring something means to multiply it times itself. So what I want you doing is I want you to write it out. 3x plus 5y times another 3x plus 5y. Again, you're multiplying something times itself, so you want to write it twice. Now we're going to take this problem and we're going to FOIL it just like we did on the previous two examples. So we're going to do our first times our first. So 3x times 3x would give us 9x squared. And our 3x times our 5y would give us 15x y. And again, it doesn't matter what order you write these two variables in. However, proper math says we write the x first because we do it in alphabetical order. So then we do our 5y times our 3x, which gives us 15xy. And our last times our last, which is going to give us 25y squared. Again, if we notice, our middle two here are both x's and xy, so we can add those together. So we have 9x squared plus 30xy plus 25y squared. Again, this is going to be our answer, and that's another example of that perfect square trinomial because we're taking the exact same parentheses and we're multiplying it times itself twice.